Hi everybody, this video is going to go over section 2 of chapter 2, and we are going to talk about the graphical displays of data. Specifically, we are going to talk about pie charts, bar charts, and histograms. Now, before we get into a pie chart, which by the way is right here, what is a graph? Well, a graph is essentially a picture of the data, and this picture will allow us to immediately view patterns within the data. Sometimes a graph will have a legend, which is a description of how each data category is identified in the graph. So for example, this lettering here, which tells you that half of your students are going to live in an apartment, is essentially a legend. And this right here is a pie chart, and as you can see, it is a circular graph. It is typically used for qualitative data. So here the qualitative data is the type of housing, and the frequency is the percentage of the students that are in that type of housing. It depicts part of a whole, and it shows the relative size for each category. Now, the kind of homework problems you might find here is like this. Here we have 1,600 students attending a local university, so slightly bigger than Limestone. This pie chart shows the housing distribution for those students. And our first question here is, well, how many students use Greek housing? Well, notice that 13% use Greek housing. So it's going to be 13% of 1,600. Now remember, when we do that calculation, we cannot work with percentages. We can only work with decimals. So 13% is equal to 13 divided by 100, or 0.13. So the students that are using Greek housing is going to be equal to 1,600 times 0.13, and that will give us 208 students. How many students live in a house? Well, that is what we have right here, and notice that is 12%. So 12% divided by 100, as you might well guess, is 0.12. I don't know why I have a 0.06 there. That should be 0.13. And if that's the case, then 12% of 1,600 is going to be 1,600 times 0.12, and that will be equal to 192. And lastly, how many students live in a dorm? That will be 25%. 25 divided by 100 is going to be 0.25. Many of you will recognize that as being 1/4. So the number of students living in the dorm is going to be 1,600 times 0.25, which is basically 1,600 divided by 4, which will give you 400. The next type of graph we want to talk about is the bar graph. Now, in a bar graph, the x-axis is typically, but not always, qualitative data, labels. The y-axis is the data values those labels take on. In this case, it is not frequency, it is per capita personal income in the year 2002. And notice here that Washington has the largest per capita income, and we can tell that because it has the largest bar and the highest number. And Rhode Island has the smallest per capita income, and obviously we can tell that the exact same way. Smallest bar, smallest number. Now, the kind of questions that you'll be dealing with in this particular type of problem is pretty straightforward. It is just finding the largest per capita income and the lowest per capita income. Now, first we're going to deal with the lowest. Well, lowest is right here. It's Rhode Island. And notice that what they want is the income, not the state. So your answer here is going to be 21,219. And the highest per capita income, there it is right there, 32,677. The last type of graphical display we're going to talk about is the histogram. Histogram is essentially a bar graph. It displays the frequency distribution of quantitative data, so it is a great way to graph a frequency distribution. The horizontal axis is typically a number line. In this case, it contains the labels are the class boundaries. And as I mentioned before, this is great for frequency distributions. Now, this is what we would call a frequency histogram because the bar height is equal to the frequency of each class. Okay, and then if you sum all the heights, you will get the total number of data elements in the data set. A relative frequency histogram will have not just the frequency history, well, not the frequency history, but the relative frequency history. And then the sum of all the bar heights will sum to 1. So here are some of the problems that you will find in relative to histograms. First, we want to find the number of the class that contains the largest number of exam scores. So this is class 1. This is class 2, class 3, class 4, class 5, class 6, just like they would be in your frequency distribution. And this one obviously has the largest number, so that would be class 2. Next, we want to find the number of people that scored between 90.5 and 100.5. Well, here's 90.5, here's 100.5, so it's going to be the sum of these two classes, which would be 6 plus 17, which will be 23. And then finally, we want to find the number of students who took the exam, and that will be the sum of the heights of all the bars. So that will be 6 plus 19 plus 10 plus 12 plus 6 plus 17. Okay, and then adding that together here, we will get 25 plus 10 plus 12 is 22 plus 10 plus 6 plus 17, 23. 22 plus 23 is going to be equal to 45. So this is going to be 25 plus 45, which will be equal to 70. And that would be our answer for the last one. Now your homework problem is similar to this, but not exactly like this. So we'll talk about that in a little more detail in just a moment. Finally, the last thing you're going to have to do is to construct a histogram, or construct part of a histogram. Now here is our frequency distribution. Here is the frequency distribution that we're going to use to construct our histogram. And our x-axis is going to contain the class boundaries right here. The width of each bar is going to be equal to the class width, which in this case will be 10. And then the height of each bar is going to be equal to the frequency in every particular class. So when you're done, it should look like this. Notice here that in our first class between 29.5 and 49.5, the height is 3. Here it is 4. Here we have 8 between 69.5 and 89.5. Here we have 10 between 89.5 and 109.5. And finally, here we have 5 between 109.5 and 129.5. And that concludes the first part of this video. In the second part of this video, we are going to go over the homework. Okay, and here we are. Here I have Hawks on the left-hand side and OneNote on the right-hand side where I can do a few calculations. And this is our very first problem. And notice it is a pie chart. And this is what we have. We have 21B Book Street Books sells about 2,700 books each month. This pie chart displays the most popular book categories by percentage each month. Find the number of reference books sold each month. Round your answer to the nearest integer. Well, here are our reference books. Notice that we have sold 13%. And 13% corresponds to 0.13. Okay? So we need to compute 13% of 2,700 books. So that's going to be 2,700 times 0.13. That was a little redundant. And if I do that in my calculator, I will have 351. And that is what goes in my window. or that's what goes in my answer field. Okay, one down, 5 to go. Here is question 2. The exact same type of problem. Here we have Maxwell. He spends 250 minutes online each day, mainly on social networking sites. This pie chart displays the amount of time he spends on each site by percentage in a day. Find the number of minutes Maxwell spends on Facebook each day. Round your answer to the nearest integer. Facebook, he spends 38.9% of his time on Facebook. So as a decimal, 38.9% divided by 100 is going to be equal to 0.389. Therefore, he spends 38.9% of 215, or 215 times 0.389 minutes on Facebook, which is 83.635 minutes. Now, we want to round our answer to the nearest integer. Notice here that at the 10th place, we have 6, which is 5 or greater. Since this is 5 or greater, we need to round up, and this will round up to 84. So that's what should go here. Okay, next one. This bar shows the per capita personal income for 6 states in 2003. So kind of exactly like our example. You want to use this bar to answer 2 questions. Which one? What is the lowest? Smallest number. It's right there, New Mexico. $25,541. $25,000. There you go. Next one. What is the largest? In this case, it's Massachusetts. 39,815. 39,815. 39,815. And there we go. And that brings us to question 4. The following bar graph shows the Electoral College votes for 6 states. Use the bar graph to answer the questions. Find the lowest state Electoral College vote total. They do not want the state, they want the vote total. And in this case, it will be for Nebraska, 5. All right, and then they want the highest, which of course will be Texas, 34. Okay, so we only have 2 questions left. Okay, the following histogram represents the distributions of scores on a 10-point quiz. Which score has the highest frequency? So remember down here, these in the x-axis are the scores. We want, and since we are looking for the scores with the highest frequency, we are looking for the score with the largest bar height. There it is. Okay. The bar height here is 14. They don't want 14. They want the score. That score happens to be 1. Okay, next one. What is the frequency corresponding to a score of 8? So you want to go down to the score of 8. There it is. And look how high the bar is. The bar is basically, its height is equal to 1. That will be our answer. The answer will be 1. Okay, now this is a problem which most people have problems with. We have to be careful how we read this. What is the total number of people who made a score between 3 and 5 inclusive? So they want to know how many people scored a 3, how many people scored a 4, and how many people scored a 5. Notice that 8 people scored a 3, 7 people scored a 4, and 11 people scored a 5. So your answer is going to be 8 plus 7 plus 11. 15 plus 11, which is equal to 26. This should be 26. And this brings us to our very last question. Unfortunately, it has 5 parts. And here is the first one. Here we want to construct a histogram that represents the following data regarding score ranges in the extrovertive tendency of respondents of a personality questionnaire. And the first one is find the lower class boundary for the second class. Now that is going to be the number between the lower class limit of class 2 and the upper class limit of class 1. Okay, class 1 is 12, or the upper limit of class 1 is 12. The lower class limit of class 2 is 13. The number in the middle, 12.5. All right, now we want to find the upper class boundary for the fourth class, class 1, 2, 3, 4. This is the fourth class. The upper class boundary is going to be the number between the upper limit for the fourth class, 27, and the lower limit for the fifth class, 28. That number will be 27.5. That is the number between 27 and 28. There we go. Now, the next part is to figure out how these divisions work. So we want to find the value that should be written in the location indicated by the question mark here. And here's the question mark. Now, how do we want to figure this out? Well, basically, we want to figure out the value per division. And that is going to be equal to what I call the division range and the number of divisions. Okay, now in this particular case, the division range is 10. The number of divisions is 5. So the value per division is going to be equal to 2. Okay, so we have 1, 2, 3, 4, 5. So right here is 10. And since we have 2 per division, this is 0, of course. This will be 2, 4, 6, and 8, and then 10. So the question mark is right here. So this value is going to be 4. Once again, since we figured out that each division is worth 2, 2, 4, 6, 8, 10. Okay, so this one here is going to be 4. Now for the next one, we need to deal with the x-axis. The approach is still the same. It's the value per division. Now notice here, the division range is 32 minus 7.5, 32.5 minus 7.5. Which is 25. So here the range is, the division range is 25. And the number of divisions is 1, 2, 3, 4, 5, 5. So each division is worth worth a value of 5. But notice that we are starting at 7.5. And we'll pretend that's our first division right here. Second, third, fourth, and fifth. So this is 32.5. Okay, so if this is 7.5, then this value is going to be 7.5 plus 5, which is 12.5. This will be 17.5, which is what we're looking for here. Now it should be 17.5, but just go ahead to fill this out. Then this will be 22.5. This will be 27.5, 7.5, and then finally 32.5. So that's pretty much how that works out. Basically find your division range, divide it by the number of divisions. That will give you the value, but it's an incremental value per division. And then this is going to be 7.5 plus the division size, division value, plus the division value, and so forth. And then finally, you need to fill out you need to populate the histogram. Now that is just as easy as taking these values here and writing them down here. So first one is a 5. What you can do now is hit tab 3 times. 1, 2, 3. The next one is a 7. 1, 2, 3. 10. 1, 2, 3. 8. 1, 2, 3. 3. And that should be it. And boom, good job, and you are good to go. Now, in terms of certification, please notice that you have a mastery of 79%, and that basically means that you can make 3 mistakes. But once again, this is a relatively straightforward homework. Go ahead and knock them all out, because even though you only need to get 3 wrong to certify, you have 3 lives. You have 3 lives before you can no longer certify again. Chances are the problem you miss or decide not to do may be the problem on the test. So go ahead and go ahead and knock them all out. It's not going to kill you. And that is all I have for this particular video. This is Bob Boyle signing off.